Hey guys, welcome back to another episode of Simuleos. It has been an incredibly long time since my last video. I think everything's up and running and it should be working. I gotta say, it's, I guess, good to be back. We'll see how long it takes and what happens today. So, how am I gonna start? Let's go ahead and open up Zernal, because that's how every episode starts. And I want to mention a couple things. So, here's the thing, streaming for me is always kind of like this kind of relaxing type of thing, you know. It's the thing that starts my day every single day, or was for the longest time, you know. From 5 to 7 o'clock a.m. I would stream, you know, and it's kind of fun, you know. I enjoy hanging out with you guys. I enjoy doing programming and stuff. I've done a couple changes over the past month or so since the last time I was here. Hey guys, that your fan Lordborn, Vitamin NC, thanks for coming in. So, a couple things I want to point out. I can't see the emotes still, guys, so my apologies. Is the stream RIP or in limbo? Okay, so let me just go ahead and address all of this. So, Cranigan, I don't know if you remember, but I used to watch your stream a lot about a year ago. I've been meaning to catch back up to your stream. No, I remember. I remember most people. Almost everyone who's been in this chat, I remember their name, and I remember them being here. So here's what happened, guys. Just to go ahead and throw this out there. Okay, so basically work got incredibly annoying, right? It got hard, and that happens from time to time. I'm a PhD student. Every once in a while, you just have to work and work and work and work for no apparent result. That's how it goes. Oh, come on, that your fan. Yeah, I'm sorry. It's been a while. But that's what happens, you know. And what I realized was, by just burying my head in the sand, you're fine, don't worry about it, and just continuing forward with my work, I started losing momentum everywhere, you know. And so I decided, you know what, I need time to set aside every day to at least enjoy one part of my day. And so I think I'm going to be back to streaming. But the thing was, with streaming, I always took these huge projects, and these huge projects were nearly impossible for me to complete. And so I decided, let's just do what we did at the start, pick small algorithms, and just, my challenge is one algorithm a week. And I'm going to incorporate all of my social media, whatever, together. So here's the idea. There was one project we started not so long ago. It was called the Arcane... oh, I can't even spell. Algorithm. Let's do this. Archive. Yeah, research has been okay. The Arcane Algorithm Archive is just, basically, you go on Wikipedia. It's actually amazing. There's this list of all algorithms. So let's do list of, yeah, of course I've Googled it before. List of algorithms here. Let's go ahead and close that. Yeah, let me just go ahead and put this in chat. Oh, no, it's not that big of a deal. Anyway, so here's the list of algorithms. Basically, I wanted the Arcane Algorithm Archive, which if we look up Arcane... Yeah, I'm sure I looked it up before. We get what we have so far. So here's the current Arcane Algorithm Archive thing. Okay, so basically you go here, you pick something, let's say Thomas algorithm. You might have to F5 to refresh to get all the math to show up. But basically... here is what one of the chapters is going to look like. Yeah, we'll be using C++, but here's the thing. I wanted the Arcane Algorithm Archive to have... basically, most of my stuff will be in C++, but I wanted this to be language independent, right? So I wanted it to have as many languages as possible. So here's what I kind of wanted to do. I wanted to have some sort of pseudocode here, and then underneath, I wanted to have a section for all the different implementations in all the other languages. So that's where it gets kind of hard, because I wanted this to be easily read, I wanted it to be easily understood, and I wanted it to be something for everyone, you know? And then I wanted just every algorithm we could think of over here on the side. So we want to do, here's something for Taylor series expansion, which I know isn't an algorithm, but hey, it's necessary. Here's something for FFTs down here. You just go into the FFT, so that's computational physics. You learn about, the Cooley-Tukey method or whatever. Euler methods, that kind of stuff. I wanted it all to be here. Verlet integration is actually rather straightforward. It's, in my opinion, the most straightforward algorithms to do force integration. Anyway, here's the point. We go through, we do all these different algorithms, and the hope The hope was that we just have this huge just compendium of stuff for people to look at. And it's one of those projects that we started, and I'm very glad we did, because it's one of those things that combines like almost all of my passions, from openness with you guys and with the community, to research, programming, writing. It's all there, and I kind of want that to continue. So I decided, here's what we're gonna do. I'm going to put a poll up on Twitter, and I realize this is kind of weird. My goal is every week, and on this we're gonna say 4 or 5, or 4, because that's as many items as we can put on Twitter. 4 different algorithms that I want to cover in the next week. Then we go to Twitch, and we code it up. This includes visualization, which we'll decide how to do when we get there. And then, after that, we're going to put it on YouTube. And at the end of the YouTube video, we ask for different implementations, and the best, cleanest implementations we put at the bottom of the chapter related to that archive chapter. And so the idea is, and with Twitch, we'll also do some of the archive writing. So we'll do AAA here. So this is kind of all how I wanted it to get done. It's going to be more relaxed than it was before, just kind of, that's kind of what I want it to be, just a relaxed kind of hangout, code together, that type of thing. So to reflect that, I've also changed the background music. You guys might not know, but I used to take specific songs from Josh Woodward's library. I would speed it up a little bit so that it seemed more, I don't know, just seemed more upbeat and such. But I kind of decided, screw it, I'm just going to take all of Josh Woodward's library and we're just going to play it at random. Because I kind of like his library, and it's nice. So I think that's okay. Let's see. I think that's about all the changes we have for now. But guys, thanks for coming in. You guys are great. And hopefully we will go ahead and see how this goes. So today we're going to cover what is, in my opinion, one of the most straightforward force integrators, and that is the Verlet algorithm. It's called algorithm. There we go. It's also known for... people use force integration too. Now here's the thing. The Verlet algorithm is the algorithm that does the integration. The force integration, my understanding, although I don't really understand why it's called force integration, because so far as I'm aware, unless I'm thinking about this wrong, there isn't actually an integral in here. By integration, they mean like adding up all of the forces on an individual object. So like, here, let me see, force integration. There's, of course, a whole bunch of different other methods that we could use. We could use Runge-Kutta, we could use Euler methods, lots of that different things. But the Verlet algorithm is one of the easiest ones. Yeah, Euler integration. Wait, that one doesn't use actual integrals, does it? Not so far as I'm aware. I feel like... Oh, yeah, maybe. Yeah, actually, now that I think about it. Okay. Anyway, point is, force integration. That's what we got here. I need to look up exactly why it's called integration, though. That's my bad. Okay, so what is the Verlet algorithm? Here's what we got. We have the kinematic, there we go, equation. Come on, guys. Very small difference with vertex, though. It's numerical integration. Yeah, but that's the thing. It just doesn't... Like, when you think of numerical integration, you think of, like, Monte Carlo and stuff like that. Or, like, you know, very basic... what's it called? Summation and such. Anyway, it doesn't matter. Let's go through. Let's work on it. Okay, kinematic equation. Here's what we have. We say x is going to be equal to x naught plus v naught t plus 1/2 at squared. Now, obviously, this comes from Taylor series expansion, right? So we do page, new page before, and we'll say some sort of variable x is going to be equal to x naught plus x dot t plus x double dot over 2t squared, so on and so forth, you know? Yeah, maybe it is just lower integrator. I don't know, I have trouble thinking of it that way, because I usually think of the numerical integration as something else. Anyway, it doesn't matter. So, anyway, Taylor series expansion, there's actually a note on the Arcane algorithm archive already for Taylor series expansion, so let me just go to Arcane algorithm archive again, because, actually, wait, it might already be there. So if you want to read more about Taylor series expansion, here it is. Again, you might have to refresh the page. I need to figure out how to solve that. But anyway, that's what we have there. And it mentions kind of what you want to do, or what where the kinematic equation comes from. But I'm having trouble speaking today. Anyway, point is, we have this equation here. And what we want to do for the Verlet algorithm is the following. We'll say that x of t plus delta t, so time plus one time step, is going to be equal to the time step before, so this is going to be x of t plus v times delta t plus 1/2 a t squared, right? This is what we have. Okay, so now we're going to say x of t minus delta t is going to be equal to r of x of t plus, minus v naught of t. Yeah, we did RK4, I think. I don't remember. Plus 1/2 at squared. Okay, so let me see. The minus here comes from the fact that we're subtracting delta t here, so this delta t becomes negative. So basically we have plus delta t, we have our regular equation, this is positive, minus delta t, that's negative. Good. Okay, so we add these together, and we get x of t plus delta t plus x of t minus delta t is going to be equal to 2x of t plus at squared, right? So that's what we have. Now we solve for the appropriate time step, and we will say that x of t plus delta t is going to be equal to, should be 2 times x of t. Let's see, what is it going to be? Minus x of t plus delta t. Oh, minus delta t plus at squared. Okay, so have you watched the show Genius? I've not seen Genius, actually. But I've heard some stuff about it. Hey, Hammer, what's up? Let me see. Slash Pariah, thanks for coming in. So let's see. So this is the final equation here. So we say the next time step is going to be equal to the previous time step plus the previous time step, and then some sort of acceleration. Do you have favorite books, shows, philosophers, or podcasts? Let me think. Favorite books, shows, philosophers, podcasts. That's a huge range. I actually don't know. I'm looking for my... Here it is. Okay, good. Favorite books. Oh, actually, there's this fantasy book fantasy book series that I used to read a lot. I really liked it. It was called The Wheel of Time. It was by far one of my favorite book series I've read. Let me think. Favorite philosophers and such? I don't know. I mean, I'm not one of those people that really looks at philosophers and thinks to myself, this guy is good. You know, I don't look at people and think, oh man, I want to emulate this guy. I don't know. I don't usually pick favorites, you know? Let me think. You know what your favorite ones are? I don't actually, not off the top of my head. I don't just think to myself, this is my favorite. You know, I don't do that often. No, I actually can't think of any that I really, really liked. But yeah, one book series I enjoyed was a fantasy book series called The Wheel of Time. It was my favorite book series for a while. Recently I've been really into, obviously, a whole bunch of like tech books and stuff like that. Reading a lot about like OpenGL and stuff like that. So that's, I don't know. I also enjoy anything on the archive. I don't know. Do you just want to be a physicist and bring knowledge to humanity while not caring about philosophical background and the big meaning? No, that's not the thing. For me, let me see, how do I put this? Look, honestly, I don't even know if I want to continue in physics so much longer. It's one of those things that, yes, I do enjoy physics, and I enjoy the idea of physics, but I feel like I make a very bad physicist, because every time I try to do anything physically, like, I kind of just sit down and I think to myself, I think about the algorithm stuff that I could implement. I don't usually think about the physical implications at all. I usually just think about the code that it would take to get this simulation to run. What about the Snarchive? I actually don't know about the Snarchive. Good philosophy, Mosey? Man, now we're talking about philosophy, as always. This is how it goes. Cool. Let's see, Snarchive. I don't know if I was aware of the Snarchive before. Let me see. Wait, what? What is this in archive? We solved the confinement problem. Motivated by this, we... no, I don't know what the Snarchive is. A parody of Archive, which randomly generates high energy... Oh, ha. Oh, that's quite good. Okay, so let me think. Yeah, so I don't know. I enjoy doing research, don't get me wrong. I really do, and I think that's one of the many things I don't want to give up on. However, the question is, where will I end up in the end? And it's probably some mixture between computation and physics, and I'm not really sure the best way to do it. Work on CS papers instead of physics papers. I kind of want to do that at times. Like, there's always this new algorithm I kind of want to implement. I don't know, all that kind of stuff. I've been reading Snarchive all this time. You go to the archive and you're like, oh, I don't know if I believe these papers. So then you go to the Snarchive, which, according to my understanding, which again I just learned about it a few minutes ago, is literally just randomly generated papers on high energy physics. And you're like, ah, yeah, this seems reasonable because everyone understands high energy physics. You know. To be fair, high energy physics is one of the many areas of physics I don't really understand so much about. I kind of wish I did at some point, because this seems to be where, like, a lot of the big breakthroughs are. But my question, I wonder if it's actually where all the big breakthroughs are, or just because you need so many people to work on it, it seems like a bigger deal than it actually is when discoveries are made. You know, that's kind of one of my questions. But regardless, doesn't matter. Focused hard on computation, less on science. That's fair enough. What's so difficult about it? You know, as an outsider, I can't really say. But I would say that the difficulty in high energy physics comes from the fact that you have to deal with much, much more difficult mathematics in order to solve the problem. I don't know. I feel like this is where... Sorry for the young guys. I feel like this is where, like, quantum field theory and stuff like this comes in, and I don't know anything about quantum field theory. I don't know anything about this kind of stuff. It's how it goes. Okay, so let's go ahead and CD into projects. We'll do Simuleos for now. Has the HLC destroyed the Earth yet? Oh, wonderful. The answer is, this is wrong. It has destroyed the Earth yet. It's just that there's a slight lag time before we feel it. So, you know, give it a few seconds and everyone will die. It's okay. So, now we're going to do make directory Verlet. Great. CD projects. Simuleos Verlet. There we go. CD Verlet. There we go. Okay, so we're in the appropriate directory. Just made it. Has to be the right directory, right? Let me do git status just to make sure I didn't do... Oh, yeah, of course, because my directory is totally clean. You know, the thing is, I've modified my git ignore file. I wonder what I did with that. Let me do git status / .git ignore. I'm sorry, git diff. Yeah, maybe I should commit the git ignore file. Okay, maybe we're in the parallel universe where it didn't. Yeah, fair enough. High energy physics is all harder to verify, as it can be pretty unintuitive. And what happens... Wait, unintuitive what happens and hard to get empirical data. Yeah, well, the empirical data is actually incredibly difficult to get. I mean, you need, like, huge colliders and such like this. I mean, it's hard. Don't get me wrong. Most of physics is hard, but high energy physics is particularly hard. What I'm doing, which is quantum physics, is nice. You know, I know everyone says quantum physics is incredibly difficult, and this is true. Quantum physics was difficult for a very long amount of time, but now it's the tabletop physics. It's the physics that you can do in a laboratory where you can see all of the equipment, and it's nice because the experiments are small scale. You get a very quick turnover between experimentalists and theory, and you kind of go back and forth. That's the truth. High energy physics is a much different scale than quantum physics. With quantum physics, you can still publish a paper with just your name on it. With high energy physics, you have, you know, hundreds of people on every single paper, because there are just hundreds of people who put every day of their life into getting this experiment to work. So let me just go ahead and add the git ignore file so I don't forget, because I keep forgetting. There we go. Okay, great. What are some of the major unsolved problems in quantum physics? I mean, there are a lot of unsolved problems in quantum physics. Let me think. Oh, what is there actually? I just said there are a lot, and I can't think of any that are really, really big. I mean, you've got like the interpretation of quantum mechanics. You know, people don't really know how to interpret it. You've got um, quantum information, of course, is a big area where people are kind of looking into how to make quantum computers. This is a huge thing. Obviously, quantum algorithms are big. You have, I guess one of them is what is quantum physics? Yeah, of course. And then let me think. Other ones, there are different questions here and there, but you're right in saying that one of the biggest questions is how exactly quantum physics relates to classical physics. You know, like at what point are we no longer in the quantum regime and are now in the classical regime? This type of thing, you know? Hey, Hammer. Oh, wait, I already said hey. Okay, so let's go ahead and get this written. We're just going to do something very simple here as a very quick test case. So quantum physics could be wrong. See, here's the thing. No, it could not be wrong. But we could not understand how it was right, if that makes sense. So basically, I'm sorry. Basically what happened was, we have a particular interpretation for quantum mechanics that seems to work, right? However, sometimes it seems a little weird. And so what could happen is that our interpretation is incorrect. But everything that we've done, all the experiments we've run, everything that uses quantum mechanics, which is a lot of things, those cannot be incorrect. You know, the experimental evidence that quantum mechanics works cannot be proven incorrect. So, in the end, yeah, we might be thinking about it wrong, but it works, you know? And so this is kind of what a lot of people do with quantum mechanics now. It's why a lot of people call themselves quantum engineers, because even though, yeah, sure, we don't really know, we aren't really 100% sure that our interpretation is right, it works. And at the end of the day, that's what matters, that it works, you know? And so we kind of shirk away the fact that we don't maybe understand the interpretation as well as we could. And that's just the truth of it. Like Feynman said, if you think you understand quantum mechanics, then you don't understand quantum mechanics. Yep. Quantum physics, almost there. That's how it's been for years. Okay, so let's go into Verlet.cpp. Yeah, let's do this. Okay. And we're going to do, I don't know. Let's just do 76A dash, and then add in this guy here, yank, paste, and let's do this, that, there we go. This is exactly how you're supposed to put a comment block in, so if anyone else tells you otherwise, they are incorrect. There we go. Let's do 15 left, and let's say Verlet.cpp. Again, this is one of the most simple force integrators there are. This works, but we can't quite control it yet. I think most things go through a stage something like this, right? I mean, fire, right? Comments, what is that? Oh yeah, of course. Personally, I like very heavily commented code. This is what I like, and I like the comments to be understandable. We get results and can replicate it, but don't quite understand why. Yeah, fair enough. Okay, so let's pop down here. Let's give this guy a purpose. And we're just going to say simple demonstration of Verlet algorithm. Okay, so this should be relatively straightforward. So what we're going to need is, first of all, include IOStream. Because, of course, I can't imagine any code that doesn't have IOStream in it. I mean, is it really code? I don't know. Okay, so now we're going to have to, of course, have a main function, as always. And let's go in here and let's go ahead and say what we want. So we're going to want some sort of function that's going to do the Verlet integration. So we'll call this function like Verlet or something. But the question is, what do we want it to return? And that is a very good question. So let's just assume we're in 1D for now. So we don't have anything really crazy to do. Graphics code doesn't use IOStream. Yeah, but is it really code? That's the question. You know, I feel like it's not. I'm sorry. Okay, very few things happen so that you are personally there and able to work on it. I don't do IOStream. Meh. What I've seen in some example codes, even for describing an API, is that they use some comments that only explain what it does, and then use such descriptive variable names as EAB. Oh my gosh, single variable or single letter variables. They are the bane of my existence. Every once in a while, someone will write a code. Oh, there was one in the code that I currently work on. Before I started working on it, there was one variable that was L. Okay. Now the thing is, L is an okay variable name. It stands for angular momentum. Fine, I get it. It's a physical variable. But the thing is, when you're searching for L in a giant, 10,000 line code, almost everything has an L in it. Every time you write in double, there's an L right there, double. You know, so it's just, you know, I feel like I agree with Happy Little Rat in that they're okay for math, but they also have to be in scope. You know, they have to be within a single function so they're easy to find. You know, if you're going to have a single variable, a single letter variable, just be sure you understand what this entails. Okay, what are we gonna do? So like we just said before, the Verlet algorithm is going to need a couple things. I'm gonna return a double, yeah, because why not? And in this, we're gonna say Verlet, and what do we want? We want to read in a couple different things. You need an editor that's capable of searching for whole words, but yeah, fine. Number one problem, kappa. Zol had JTV. Angular momentum equals regular search, Kipo. The problem is the API developers doing that in examples. Something you need to spend more time learning than using. Yeah, that's true. To be fair, I don't use regular expressions. The thing is, I want my code to be simple and understandable, right? And when it comes to making things simple, okay, you could argue that regular expressions are simpler, just not as understandable. And in my opinion, I would much rather write code that everyone can read and understand than code that is very difficult to understand. I don't want to look at my code and think to myself, wow, I was pretty clever when I wrote that. I want to look at it and think, I understand this. I don't know, I kind of like the fact that we can't see emotes in chat. I know it's a big thing, emotes on Twitch, but it's kind of fun, you know? Everyone's like, Kipo, and I'm like, ah, great. I know that you use this emote that I don't know what it looks like, or forehead. Okay, what are we going to say? We need a couple things for this. So we need previous position. So I guess we're going to put in double previous position. Now what do we want? We are going to return the current position. We need double acceleration. What else do we need? We just looked at this. Oh, and we need the current position. So let's say double current position here. Okay. And let's pop down here, and this should be what we need, unless I'm missing something. Oh, and DT. Good, this should be about right. I prove the emote list. Hey, Bugsby, what's up? Some people, when confronted with a problem, think, I know, I'll use regular expressions. Now they have two problems. Just realize that you are programming at 5 in the morning. I wish I was not lazy. Here's the thing. I've always been one of those people that get up really early. In fact, over the past few months, when I wasn't streaming, I got up at freaking 2 o'clock in the morning, like almost every single morning, just so I could work. And I worked from freaking 2 o'clock in the morning to like 6 or 7 o'clock at night when I just crashed, you know? And the thing is, I finally realized that I needed a break, and that's why I'm here. You might spend more time thinking than screwing up. Yeah, okay, yeah, true. Okay, Verlet, this is what we have. Okay. I think this is all we're going to need. So let's just go ahead and create the Verlet function. So double Verlet. I'm just going to yank and paste this. Screw it. It's easier. Pop down here. Oop. Pop down here. Open this guy up. And we should have a very simple... Oh my gosh, what am I doing? Holy crap. It's like I haven't programmed in like months. We need to start working on the archive. Haven't been here since ages. To be fair, I started the archive a few months ago, but again, we had a bit of a hiatus. Maybe we should call this, Lordborn. You know how this channel works. 30 minutes in, 3 lines of code. That's actually pretty good, you know? Like, it's been pretty good. Okay, Verlet, what are we gonna do here? Sorry for that. So in here, we're just gonna say we have some sort of previous position. So we should just be able to say, position... return position, and then down here we're going to say position, and let's add in semicolons because, you know, semicolons is going to be equal to, what do we want? We'll be uploading today's stream on YouTube. Yeah, I think I will. 10 years we'll have to merge sort implemented. Oh yeah, merge sort. Yeah. Hey, actually, to be fair, we did get a lot of stuff done at some point. Hey, Slayerdar, thanks for coming in. We had, worst sort was amazing. Man, I loved doing worst sort. It was the best. And the gift wrapping algorithms, also fantastic. There were a lot of stuff that we did that was actually quite fun. And I'm very glad we did it. I need some water. I'm getting thirsty. But I mean, that's the thing. I think I think at this point, my interests are like in learning the different algorithms and things. So that's why I'm kind of challenging myself to do an algorithm a week. You know, I haven't decided which visualization we want. The curtain back here. Okay, so worst sort was the worst sort, but it was fun. Okay, so a while ago, I had a green screen behind me, but the truth is, my room is a finite size, and this green screen really hardly fit in my room at all. And I wasn't really a big fan of the green screen anyway, because the green screen just, I don't know, I couldn't get it to work for the YouTube videos, and it just didn't feel right, you know? So I removed it, and now, I don't know, you guys can see into my room, it's fine. There's my bed back there, which, one second, let me remove that blanket. What's the great news, Slayer Darth? And Zedison knows not to conceal the ocean. I changed rooms, so I'm no longer in the, Oh, is it really? Oh, that's quite neat. Let me do that. Woo! Oh, that's quite nice. Actually, I don't know, guys. Ooh, altreligion.emacs. Okay, what was I gonna say? Yeah, so Zadison, I'm in a different room now, so the ocean is no longer around. I apologize for that. I was thinking about getting a time lapse of like the sunrise or something like that one day and just like posting it. Like here's my face over here, maybe posting it next to my face or something like that. What else was I gonna say? There was something, you guys brought it up, now I don't remember. Oh, yeah, I realized on YouTube I have over 7,000 subscribers, and that's really good. In fact, like, it's better than I could have hoped, because I haven't posted videos in 3 months. And part of the reason I decided to come back was just because, I don't know, if people are enjoying me doing this, if people are enjoying learning algorithms and stuff in this way, I figured, why stop it? I mean, it's only encouraging people to code, you know? Was that an organic result? Wait, what do you mean, was that an organic result? Or did you flash Google that? No, I didn't do anything. I mean, I made some videos. To be fair, like, if you look at my videos, let me just go to YouTube. Here's the thing. You go to my videos, and this video has it has 650,000 views, right? So it didn't go viral, but it went semi-viral, you know, compared to all my other views. See, this one has almost an order of magnitude more videos than my next highest video, which is what is an eigenvector. And then, like, I have some videos that have, like, only 2,000 views on them, you know? So that's how it goes, you know? I guess every once in a while you just get one of those videos that everyone seems to like. And for me, it was the Understanding 4D, the Tesseract one, which I guess makes sense because everyone looks up four-dimensional stuff at some point, I guess, you know? I don't know. Okay, what am I doing? I need to actually get this written. So let's do something very simple. We're going to say the position is going to be equal to 2 times the current position. Let me see. Then we're going to want it to say, one second, current position. What am I doing with my life? Plus, we don't need v naught t. We're just going to need acceleration times delta t squared, so dt times dt. And then the last thing we're going to need is plus previous position minus previous position. What am I doing? What is this math? This is not right. Something like this. Yeah, whatever. I should probably put this in the right order. Let's just go ahead and move this here. Put it over here. Minus... Come on, what am I doing? Minus previous position. Something like this. Okay, so here's where our first problem comes in. Eigenvectors. I know the word. By the way, I've been filling the gap Stimuleo streams. Oh, what have you been filling in the gap with? Okay. This should be correct. However, we have one bit of a problem. Put a clickbait title like, is quantum physics all wrong? No. I do not agree with clickbait. Here's the thing. If you're going to get people to watch a video, it's got to be, you know, just with the thumbnail. Who cares about the clickbait title? I mean, your thumbnail needs to be like the most interesting thing you could possibly imagine, which is why, of course, all of my thumbnails on my YouTube videos are by far the most interesting thumbnails you could imagine. I mean, look at this. Look at those thumbnails. Those are great thumbnails. Who cares about the title? I mean, what is an eigenvector? No one Googles that, but that thumbnail, that's what's going to get them to click. No, but in all honesty, like, I do kind of do this clickbaity thing in that no, I'm not going to do 10 facts that'll blow your mind. That won't work. But I do the clickbaity thing in that people will Google certain questions, and I will I will put that question in the title. So what is an eigenvector? This type of thing. So that's what I do. Understanding four dimensions. That's another thing that I'm sure people have Googled before. So let's just say simple function to use Verlet integration. There we go. That seemed to be right. Yank this, paste it down here. Let's go ahead and get this guy working. So we're going to say, let's drop a ball from 5 meters high, right? How long does it take for a ball drop from 5 meters to hit the ground? 10 facts about nuclear bombs that will... Oh. Lordborn. Okay. Here's the question. You drop a ball from 5 meters. How long does it take to hit the ground? Everyone says... There's a 20-second delay. This is actually a really bad idea. Let you guys think about it. 5 meters. Drop a ball. How long does it take to hit the ground? Assuming gravity is a flat 10. Okay. So, let's do it. We're going to say... we're going to need a while loop. So, while... Oh my gosh. While position is greater than 0. Look at this notation. Oh my word. I'm doing it. I am programming for the first time ever, apparently. Double position. Let's just call it pause and previous pause. Prev. Pause. There we go. Okay. T equals 1. There you go. It's super easy, right? We're just going to do that because we should get T equals 1 and it shouldn't be that big of a deal. We're also going to want double time. Oh, come on. Why did I write double time when I'm already defining it as a double? What am I doing with my life? So we're going to set position equals 5 meters. We know accelerate. Why did I put an M? What am I doing? Like, seriously, I feel like I've never programmed before in my life. Okay, so here we got that. Now what are we going to do? We're just going to say Verlet. Position is going to be equal to Verlet of, and what we need is the current position, which is going to be position. Then we want previous position, which is going to be previous position, and then we want acceleration, which we're going to say is -10, and finally dt, which we're going to say 0.01, something like this. Okay, and then what we want to do is just add up all the time steps. Hey Ginfira, what's up? So we're going to say time. Yeah, let's just, and we're going to say time. Something like this. Yeah. Using spaces instead of tabs. Come on. Come on. Who uses tabs nowadays? Actually, wait, guys. I was going to make a video on how to use VI, right? Not Vim, VI. And like my first comment was going to be, imagine you're in 1976. So first we need to, oh my gosh, I misspelled time. Oh my gosh. My first comment was going to be like, first we need to look up this, what is it? There's Editor Wars. Wikipedia. Everyone knows about the Editor Wars, right? Like, I'm sure everyone does. Okay. But anyway, I said you need to look this up, but in order to look it up, you need to do it in, obviously, the most appropriate browser for this, which is Links or eLinks. So we'll just say eLinks, because I'm sure I have it. There we go. HTTPS en.wikipedia.org/wiki editor war. Here we are. Oh man, that color scheme. That color scheme is awful. Is it using my Vim color scheme? Anyway, doesn't matter. Maybe I should just use links for this. Yes. Links. Do I have links installed? I do not. So let's do sudo pacman-s links. There we go. That's not how you spell Pac-Man. There we go. Oh shoot, I'm teaching a Linux skill pill tomorrow. Alright, let's do it. There we go. Okay, perfect. So now you have the browser. Anyway, it says in here, where does it say? It says, the editor war has yet to be resolved with a clear winner, and the hacker community remains split 50-50. Alright, it says that. Links also works, yeah, the other links. But I don't know if this is true, because I feel like I've seen so many people using Vim and VI, but I've seen very few people using Emacs, you know? So, I don't know. Yeah, and links, L-Y-N-X, of course. Everyone knows that one too. Sorry, it's just I chose one at random. Previous position. So we're going to say position equals this. We're going to say previous position equals position. Is this stupid? Yeah, that's really stupid. What am I doing? One second. I have to think about this because I didn't think about this before stream. I should have probably written down pseudocode or something. Previous position is equal to position. Nope, this should be afterwards. So here we're going to say, and we're going to say, yep, something like that. So here 5 and 5, and then the next time, no, they're going to equal the same thing at all times. Isn't that true? What am I doing? You want the previous position. Okay, wait. We need to store the previous position somehow, which is going to be the position before the current position. So we say position is equal to 2 times current position, which we're going to be reading in. Okay. And then we want the position of the last time step, right? The problem is, let me think here. The position of the last time step is going to be... Gosh darn it, why am I having trouble with this? I usually don't have any trouble with this, but I think it's just because I haven't streamed in a while. Someone responded to the statement, Emacs is a great operating system, lacking only a decent text editor, by running VI inside of it. Wait, did they really? Because that's amazing. That is probably my favorite comment I've ever heard. Okay, so what do we have here? We need a couple different things. We need position, which is position of the current time step. So we're going to say position, let's do x of t plus 1. There we go. My t's and pluses look identical. There we go. They still look identical. Okay. X of t and x of t minus 1, right? You don't need a temp to store it. Shrug. Maybe not. 1 second. Let me think. These are the 3 guys we need. So to solve for t plus 1, we need these guys here. Okay. So we have x of t. And then we want x of t minus 1. So obviously they both start at 5. So this guy starts at 5. This guy starts at 5. This guy goes to 4.9, right? Because that's like, it drops just a little bit. Okay? So then this guy turns into this guy. Right? And this guy turns into that guy. And then we solve for the next position. Oh, so it would be before. But then we're reading in 4.9 twice. 1 second. So at this stage, we would have 4.9 and 5.0, right? Okay. Ooh, let me look at this. What do we have here? Oh wow, that's amazing. Where is this in? It's Asia somewhere. China, I guess? Because this is totally Chinese. Yeah, this is Chinese. Hey, fled from now here. Nowhere. You told me it was now here at some point, and I can't get it out of my head. Okay, position, Verlet. Okay, so what we need... I'm sorry, I was scratching my... You probably heard that in the microphone. Okay, so the next one's going to be 4.9 and 5.0, right? So we say x of t plus 1, and this is going to be 4.8 or something. Whatever, it doesn't matter. Okay. The image is from 4chan? Yep. Okay. So what we want then is the previous position to be stored in x of t minus 1. It's easier if we just have a vector of all the positions, but I don't want to do that. I want to keep this without that for now, because it's easier without that. I say it's easier, and for some reason I'm having trouble with this. I usually don't. I promise I don't. Okay. RBT Asia is 4chan archive site. We threw a birthday party for my sister at home yesterday. It ran from 7 to 2 in the morning. Wait. 7 at night to 2 in the morning. Oh, okay. I thought... Yeah, okay. That's fair enough. How old is your sister? If your sister's like 3, I feel like that party wasn't for her. It was for you guys. Okay. What do we have here? Previous position. Previous position. All the preparatory work and then the constant partying just drain me. Yeah, I hear ya. I don't know. Rebecca Black Tech. Don't ask me why they use that name. Oh, interesting. Yeah, last night we went... I was supposed to have taiyaki with people, but I just went to the kitchen where everyone was doing taiyaki. It was the community kitchen that we have. And there were just too many people there, and I just said, screw it. I'm leaving. I was there for like 5 minutes. I brought in sweet red beans, and it was done. Oh, 21st birthday. Yeah, that makes sense. Okay, what am I doing here? Okay. So, we say they're both equal to 5.0 at the start, which is true. Then, the next time step, we say 1 is going to be equal to 5, still. And the next is going to be equal to 4.9. Okay, so, yeah, is the fish... Yeah, here, like... Maybe I mispronounced it, but... Yeah, this guy. You put whatever you want in there. So I made the sweet red beans to put inside. It's quite good. I enjoyed it a good bit. Well, I'm sure I would have. I didn't eat one, actually. I just kind of pieced out. Okay. Oh my gosh. What am I doing with my life? There we go. Previous position. Okay, so now we just have to store the previous position, which shouldn't be too bad. I can't watch your stream because it's too high quality. My internet is... Oh, okay. Well, here's the thing. I eat much in Japan due to my seafood allergy. Oh, but this has no seafood in it, actually. The fish has nothing in it. So when I run my stream, I run it with a bitrate of 2000. Usually I get quality options, but I think maybe I don't now. Let me check my bitrate right now. My bitrate should be 2000, I think. File, settings, stream, output. Yeah, my bitrate's 2000. So it's pretty low, actually. But yeah, so I usually get quality options. I just don't think I did this time because it's been a while since I streamed. Okay. Yeah, it's just... Yeah, what am I saying? Okay. I'm sorry. I have to figure this one out. I'm sorry this is taking so long. I'm an idiot. This is how all my streams go. You've been off stream for too long, so they stopped providing replication? Yeah, I think that's what happened. Do you like the sushi there? I mean, I don't eat fish, so it's okay. Like, I went to a sushi place, and actually, the sushi places here are quite interesting. You have, like, these giant... I think it was because I had a YouTube video loading in the background. Really? Well, okay, good. So the idea, you go into these, like, huge restaurants or whatever, and, like, there's this conveyor belt of sushi that kind of goes around the entire restaurant. I'm not actually allergic to the fish oil, just the protein in the fish. This seems weird to me. Like, is somehow fish protein different than other types of protein? Anyway, point is, you have this giant conveyor belt, and you take all these different plates and stuff like that. And at the end, all the plates are the same, so they just count up the number of plates that you bought, and they say that's your price or whatever. But the cool thing is, they have this little trash bin or receptacle or something that you put all of the plates into. And every time when you put in 4 plates, or at least the place that I went to, they start, or they do this weird, like, I don't know what it is. It's like this game where you can buy like some sort of lottery type of thing, you know? It's like you put in 4 plates and then you're a winner. You get like this little figurine or something in one of those little balls, those little Pokeball type things. It's possible to acquire an allergy to red meat from tick bites. Yeah, I've heard this. I know that's definitely true. Okay. What am I saying here? So, Verlet, position, previous position. This means that we're going to want to read in. So let's see. We're going to read this in. We're going to say position is equal to this. We read in the previous position. And then we say previous position is equal to this. That's not true. It has to be up here, right? So let's see. It's going to be 5. So now we say it's equal to 5. We go down here. We say 5, 5. Okay. So it seems to me like we need to do this twice, actually. So let's see. Position. Maybe we need current position here. Wait. I'm having trouble thinking about this, and I don't know why. We've done this like 1,000 times before. Okay, let me look it up in my handy dandy notebook. I don't know why I'm having trouble with this. I'm really sorry about this, guys. It might be because it's the first time I'm back. I don't know. This just happens. Color quantization. Oh man, color quantization. I just remembered about that. So we're gonna say, what do we have here? T. R of t plus delta t is gonna be equal to R of t plus V of t. Let's see, A. It's supposed to require allergy to red meat tick bites. Yep. I'm sorry, this is probably not entertaining at all because I'm not getting anything done, and I'm very sorry about that. Okay. Velocity changes, but we don't keep track of that with the Verlet algorithm. I was going to show you guys that in just a second. For some reason, though, I'm having trouble with like the simplest thing. Okay, we need a previous position. We have a current position. At the very least, it should compile. So let's do g++ Verlet.cpp. Yep, compiles just fine. Okay. So what are we going to say? Then at the end here, we want to do time, and let's do end. Okay. So what are we going to do? Don't you need just temp equals position equals Verlet, previous equals temp? Probably. Let me think. Yeah, that's what I was going to do just a second ago. Current position. There we go. So we're going to say dd paste. Okay. So we're going to say current position is going to be equal to position. Then we're going to say here we're going to do current position, and then we're going to say previous position equals temp. You're right, that should be it. 1 second, let me think. So here's the thing. I literally just coded this up this past weekend, and I did this without any problems. So current position is equal to position. Fine. We read in current position, previous position. Yep. And then we say current position equals position. Yeah, something like this should work. Let's go here. Let's do g++. Let's do a.out. 1. Great. That's fantastic, except for the fact that it's 1 exactly, which kind of makes me think that I'm doing something wrong here. So let's do 5.5. Let's make that a.out. Yeah, okay, fine. Fair enough. Seems to work. Great. Good job, team. Only took 20 minutes to do this, or like an hour to do this. Holy crap, what am I doing with my life? Okay. Now, if we want the velocity at any given moment in time, the velocity can be computed straightforwardly with new page before, x of t plus delta t minus x of t minus delta t over delta t. Right? Change in position over change in time. So, yeah, something like this. See, output position is quite low at default, I think. Yeah, fair enough. Sorry about that, guys. I don't know what I'm doing. But for some reason, I just can't think right now. That's okay. Doesn't matter. Okay. So that's how you calculate the velocity, because it's just change in position over change in time. And that's relatively straightforward. Okay, so now the question is, how do we want to visualize this? So obviously, we can plot out all of the positions. So let's do it this way, just to show that it works. Let's do Oh, you can also do it that way. Yeah, that's another way to do it. So v is equal to, yeah, exactly that. That's another way you can do it. Yeah, it just depends on when you want to calculate the v. If your a depends on v, then if your a depends on v, then you don't want to use a in the v, I think. Something like this. Okay. Probably that one is more algorithmically stable, right? Yeah, actually, let me think. Probably, yeah. Yeah, probably. Okay, so let's go in here and let's do include fstream. And let's, okay, come on. Yeah, this is probably true. Okay, so we have some sort of position here. What we want to do is we want to output stuff, so let's do fstream of stream file, and we're going to say file. Hmm. I totally forget how to do fstream every single time I do it. Holy crap. I think it's particularly on this stream it's bad. I just can't remember how to do anything on this stream. Oh my gosh, every single time. Come on, I just want a freaking example of stream. There we go. That's all I want. It's really that easy. Okay, let's go up here. I know. I'm sorry. I'm just really bad at it. So let's do out.dat. And what did they do over here? Oh, they did std of stream out. But I think that's probably standard. So let's go down here and let's say what I want to do is output all of these positions. So we're going to say previous position here, and I want to do file. And let's do position, new line, something like this. And let's do file dot close, something I think should work. And of course it's G++ because I haven't created the make file yet. Let's do a.out, let's do ls, and we should have an out.dat, vi out.dat. Seems right to me. Now let's do GNU plot, and let's plot out.dat. With lines. Great, okay, that probably is okay. Let's let it fall for a little bit longer. You don't need that flag for upstream? Yeah, probably. Yep. I'm sorry guys, I'm just failing miserably today. Okay, get rid of that. And let's go ahead and put this at 50. Let's go over here, let's run G++. Yeah, that should do it. Oh, come on. That should do it. Now let's do a.out, and let's do GNU plot out.dat. Yeah, okay. I mean, you see an acceleration pattern. I was expecting it to look more like for this to be a steeper slope in the end, right? That's what I was hoping for. Let's see if we can get that. I feel like increasing this should do it, maybe. No, it looks exactly the same. Why did I think that would happen? Let's see, add platforms. It might actually cause problems since you didn't add. I've had run into a problem. It wouldn't create the file without the flag. Oh, interesting. I've never run into that problem. Start with the greater height. Yeah, I did, and it didn't seem to do anything different, right? Because you'd think with a greater height, first of all, is that correct? It should be 14.14 for a height of 1,000. So let's see. The exact formula should be, let's just solve it real quick. New page before. We should say x, obviously x is equal to x naught plus v naught t plus 1/2 at squared. Let's go ahead and get rid of this guy because we'll say v naught 0. So now we'll say t is going to be equal to the square root of, one of these is also going to be 0. We'll say x is equal to 0. because that's going to be the final height or final destination. So now we're going to say negative x naught over negative 2x naught over a. Yep, that's it. Okay, so we'll say x naught is equal to 1,000, so t is going to be equal to square root of negative 2,000 over negative 10. Okay, so square root of 200. Okay, let's see what we got here. Square root of 200. Let's just open up Julia. Square root of 200. And 14.14. So that is correct. It's obviously down to some precision, which is dependent on, you know, what we chose. We chose DTD equals 0.01. We could change that precision, and that would change the underlying code. Okay, good. So now the question is, what kind of visualization do we want to do here? What I want to do, I'm going to assume this is working just fine, because it seems to be working just fine. The acceleration pattern seems a little bit weird to me, but that just might be because I'm not, you know, I'm not looking at it right. What do you call those meat pancakes you have in Japan? I don't know what you mean by meat pancakes. Hamburgers? No, let me think. Meat pancakes. Japanese meat pancakes. Oh, these guys. The Okono... Yeah, I don't actually know what they're called, but I've had them before. Is this what you're talking about? Yeah, you don't... Actually, they're mostly cabbage. With a little bit of egg inside, and then you put other things on top of them. So they're not really meat pancakes. They're just kind of like cabbage with other stuff on top. It's actually vegetarian a lot of times, except for when they put these freaking fish flakes on top of things, which they do everything. Everything has fish flakes or bacon bits or something like that. It's like you order a salad and you're like, I don't really want to eat meat today. And then all of a sudden it's just like, well, okay, I hope you're not a vegetarian because we put bacon bits on it. And it's like, dude, I just wanted a salad, you know, like, I don't know. They put fish flakes and ham and everything. It's just, it's hard. So basically, long story short, don't be a vegetarian in Japan. Doesn't work out. Okay. So let's go ahead and do Control D here. This seems to work. Now let's talk about the visualization I want to do. New page before. Okay, let me think. So, obviously, the nice thing about the Verlet algorithm, as opposed to like what we just did, like dropping a ball from 5 meters, anyone can do that. Now, what the interesting thing about this Verlet algorithm, or really any force integrator is that you can do more complicated things with it. Now, the question is, what other complicated thing do we want to do? What I'm thinking is, you know, something straightforward. We have a planet here. We have an asteroid here. The asteroid wraps around the planet. Okay? Something like this. Now the thing is, I feel like this is okay, but this is still solvable by it's still solvable by like analytical methods pretty easily. So maybe we add a couple other planets and just see this guy wiggle around. I'm not sure. What do you guys think? Like, I want some sort of complicated... let's make this guy a different color, just so we... So he's going to go whoosh, 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 something like that. I don't know. Maybe there's a way to make him do that. I feel like that'd be really difficult. Oh man, but that'd be awesome if we could pull that off. Just... Okay, sorry. Okay, but the point is, I kind of want to do a more complicated visualization of some sort. I just haven't decided the best complicated visualization to do. Motion of heavenly bodies. Yeah, of course. I'm going to put a pink P on these guys. Are you doing gravitational simulations again? Well, no. So here's the idea. P. And then this is going to be asteroid A. I remember I was talking about the possibility of having competition for the channel. Oh, yeah. Let me check this out. Kaggle, datasets. Why not do something working with open datasets? Let me see. What do we have? Like, do relativistic physics? Actually, I don't know very many algorithms in relativistic physics, if I'm being honest. Opinion? Some of these could be good. Some of these could not be good. It depends. Yeah, so we'd have to cover stuff up. Like, we'd have... not cover stuff up. We would have to... what am I thinking? We would have to do an algorithm that deals with big data first. So I think that's what we need to do, which we could do. Okay, so the first one looked good without the extra planets, you think? What I'm thinking is, okay, now here's the thing. Two things. First of all, if we're going to do this, we have to choose which visualization method we want, okay? We have two possibilities right now, both of which are subpar. I'm just going to be honest. One is the scientific visualization library, which works pretty well. You know, it's what we use for the Fourier transform video, and in my opinion, it works okay. You know, the nice thing about that is we could do it in this way that allows people to basically play it as if it were a game. So like what I'm thinking is we have some sort of box. How do we put this? Some sort of box, you know, that is your screen. Here's your screen. And then you choose where to shoot your asteroid, right? And then the asteroid kind of moves around based on where you shot it. Or we can do it with the Cairo visualization, which I use for most of my videos up to this point. And that one's relatively straightforward. We just write out an image every time step. This tends to look a little bit cleaner, in my opinion, in the end, because we basically output images of whatever resolution we want. The problem is, when we're outputting videos of whatever resolution we want, if the resolution is high, it takes literally a full day to render. STL and OpenGL, yeah, that is the SciVL library that we have. Oh, I'll shoot my asteroid. Okay, so everyone wants the one where you can like play it like it's a game. Big data challenge would be great. Yeah, I think that'd be good, but we need to cover a big data algorithm, I think, first. Oh, by the way, guys, I just wanted to point this out. There is, again, I mentioned this at the start of the stream, there is kind of new music on the channel, so if you like the music, let me know. The music is still from the same artist. It's still from Josh Woodward. I really like his stuff, and I kind of want to support him as much as I can, but I've decided, you know, it's going to be just kind of more chill music instead of the upbeat music that I used to use. So everyone wants to do the scientific visualization library one. Here, let me just give you an update. You don't hear any music. You should hear music. Let me pop over here. Maybe it's too quiet. Oh yeah, that is quite quiet. Maybe I should increase it? I usually keep it at -30. That's why I keep it on. It's okay. Don't worry about it. Fine. Whatever. Doesn't matter. Let's talk about the visualization library we have right now. Let's go ahead and commit this just to say we did. Git commit add Verlet git commit -m adding simple Verlet example just to say we did. Git push origin master. Oh my gosh, we are doing so bad. Hey, Droin, thanks for coming in. Okay, good. Okay, what am I gonna do next? I'm gonna do into the visualization library cd //scivl git pull origin master beta. What am I pulling? Where am I? Git branch. Git pull origin, and then my friend's name Thomas, because look at me. Okay, there we go. Let's go here and let's cd scivl. Yes, what is the other request? Slayer Darth. There's also classical public radio. Oh my word. Like, if I started playing classical music on this channel, I don't think I would hear the end of it. Like, the thing is, classical music is typically for, like, people who think themselves to be smarter than they actually are, you know? Like, it's one of those stigmas. And now, don't get me wrong, I love classical music. In fact, I have a viola over here that I can't play, but I've been wanting to play for a while. Could you maybe do something like a Gitbook glossary of terms you've covered on your channel? Yeah, in the end, actually. Like, nice definition of Fourier transforms, for example. Quickly reference. Well, if you go here, and you go to FFT, F5 to get the... What is a Fourier transform? I feel like this is pretty good. Oh, except I apparently didn't put in the figures. Oh, apparently I had figures I wanted to put in, but I haven't put them in yet. I'm very sorry about that. I'm sorry. I'll update this. I promise. Okay, but yeah, there is in principle that's kind of what I wanted this to be. You know, I wanted everything that we covered on the channel to be in the algorithm archive. Ah man, I need to update this. I need to read through this and figure out what I was intending to do when I wrote this. We also have, of course, Gaussian elimination, which is another thing we covered. And we have Thomas algorithm, another thing we covered. Hindsight, which is basically why I started programming to begin with. I even have a section on choosing a language, right? And I say, I have a perfectly healthy habit of personifying things. I figure a good way to properly distinguish each language from each other is to list the common ones here with a small description of their typical uses. Okay, obviously, I'm getting there. The only language I have under choosing a language is Fortran, which is, old. Yeah, so, here, let me go ahead and, where is it? Just go to the algorithm archive right now. Here, let me go ahead and give you this link. I think that's the right link. Let me check it. And you should have access to everything here. So, yep, that's kind of the goal. What about Rust? I didn't put Rust on there. I'm sorry. I don't know enough about Rust. But yeah, I wanted this to be, I don't know. I've always had this idea. Or rather, I've had this idea within the past few weeks. Okay, here's the idea. Solitary experiences. Reading is a solitary experience. You do it on your own. Writing, another solitary experience. You do it on your own. Art, all these things, you do it on your own. You don't typically do it. I'm missing languages. I'm sorry, guys. I'm sorry. No one uses D. Holy crap. Java isn't a real language. Wait, but it's there anyway. D was already asked about. Anyway, point is, solitary experiences. We have a whole bunch of solitary experiences. I'm just gonna put freaking white space on here, guys. White space. Language. You guys know about this one, right? It's one of my favorite languages. It's literally, you code in the white space. No, I know, I'm joking. Anyway, so you have all these solitary experiences. Gaming is one of the things that can be a solitary experience if you play the appropriate games, but could also be Markdown. Might as well just put LaTeX up there too. But gaming can also be a social experience, and Twitch is one of those ways that gaming becomes a social experience. And I've been kind of wanting to make programming somehow a social experience, so this was kind of part of my idea with the algorithm archive. I wanted to get people involved in the process of learning and producing programs, and so that was kind of why I wanted to have this challenge, in a way, of people implementing an algorithm a week with me and that type of thing. Are you running Arch on your laptop? Yeah, I run Arch everywhere, actually. I can't think of, yeah, my old laptop ran Arch, my old laptop ran Arch, my computer runs Arch, everything runs Arch. What is this guy? Total number of D users. Is that correct? What was it? D users? I don't have a phone. My toaster I don't use. Actually, wait a minute. Actually, that was a really good link. Okay, I'm sorry. Yeah, I don't have a phone. Oh, my tablet that I use for my, like, stuff. That one doesn't have a, anything on it. Okay, let me go back over here. Let's make this. Literally, we've done nothing but talk, which is fine. Don't get me wrong. I like talking to you guys. You guys are great. But, let's see if we can get something done. So I'm making the scientific visualization library right now. If we run /scivl, let's run, there we go. We get some sort of resolution, which will say is 500 by 500. Actually, let's do 1000 by 1000. And we're just going to do, let's do simulation platformer. Just to say, okay, that went full screen for some reason. That's a bit of a pain. 1 second, why did that go full screen? No. Why is it going full screen? It shouldn't go full screen. What are you doing, dog? Let me move this back to where it's supposed to be. One second. Let's try a different one. Let's do Pong. Why is it going full screen? It shouldn't go full screen. Okay. Usually this works, but for some reason I'm having trouble getting it to work right now. Let's see. Why would it go full screen? Let's do SciVL -H. We should have, yeah, there should be a full screen mode. So let's do -F and see if that makes it full screen. Of course it makes it full screen. Okay, so first issue, let's go ahead and solve this so that it doesn't put everything full screen all of a sudden, because that's kind of a pain. So why is it going full screen? That's a good question. Let's go into VI source. We have a bunch of things in source, so let's do GL setup. Let's look for full screen. If par full screen. Okay. Okay, so only if par dot full screen, which I don't think we set. Let me see, what did I miss? No phone? Yeah, I don't have a phone. What about JavaScript? It's the same as Java, right? Yeah, it is exactly the same as Java. One's just a scripting language for Java, right? So it's obviously how it works. GL setup dot, let's do full. No, I just went in here. Distributions full. Why is it always going full screen? That doesn't make any sense to me. I mean, it works when it does go full screen, which is fine. But why? Let me see. What if we do... what do I want here? It always says entering full screen mode there. Wait. It doesn't say entering full screen mode here. I'm annoyed that my laptop's BIOS disables the integrated GPU, so I can't run Linux with PCI pass-through to Windows. I don't really know anything about that. I didn't realize that was an issue. Wait, what exactly is PCIe pass-through to Windows? What do you mean here? Does this mean, like, if you use a virtual machine to run Linux, you can use the GPU on Windows? I'm not sure exactly what it means. Sorry about that. Let's see. How are your pop shots? I don't know what pop shots are. And apparently, wait, pop shots or whatever they're called. Pop shots. I'm not sure. Oh yeah, I see what you're saying. Yep. Yeah, that'd be nice. Okay, what am I gonna do? Let's just go into distributions.cpp. Oh, maybe VI source parser. .cpp. Let's do full screen equals false. Yeah, it says it's equal to false. What if what are you teaching, fellow students? Were you teaching fellow? Oh yeah, the skill pills, I think is what you're talking about. Let me see, is that correct? Yeah, skill pills, that's what they're called. I'm going to be teaching them Linux stuff tomorrow. I need to do the course today. But basically tomorrow we're just doing like configuration and stuff of Linux systems, so it's nothing really complicated, just packaging and things. Found out the reason I couldn't stream anything was due to my antivirus? What? Who uses antivirus? I'm sorry, that was a joke. Please use antivirus. That requires 2 GPUs, one for Linux, one for virtual machine. What is there to teach about Linux? There's actually a lot of stuff. People don't really know. So there's a lot of stuff to teach about Linux. There's a heck of a lot of stuff to teach about it, in my opinion, of course. Okay. My question, what if I set this to false? Let's set this to false. Go here, let's make that. And yeah, that's all there is. Sudo apt-get update. You're done. Let's try running this again. Yeah, okay. So somehow the commands are bleeding together. Why is that the case? Okay. Make a video about it. Let me see something. Let's set this to be true. make it again. Oh, actually, did I write this? Make clean, make. Give it a second. What about the time we live in? Wait, what a time we live in when you need to say, in my opinion, to not offend someone. I mean, sudo su rm. Yeah, that's wonderful. Yum install wine. Yep, there you go. Sudo apt-get update. What are we saying? To Lordborn, to answer that, I feel like, I don't know. I mean, it's nice to say in your opinion to things. I mean, I don't see anything wrong with it, you know? If someone's getting offended because of things you can't help, like, you know, if you... Let me think. There's sometimes people do get overly offended, you know? Like, if you're just making a joke and you mean it in the kindest way possible and they take it incorrectly, that's fine. But, I don't know. I say in my opinion, and I think it's okay. I've been using Debian as a server for quite some time. There isn't really anything difficult about that. Maybe for someone as an OS to use on their computer, maybe. Actually, James, you can probably catch out unsuspecting folk with fork bombs. Yep. Hardest thing I had to learn was how to exit Vim. Oh, yeah. What is it? Let me go over here. What a time when being nice is offensive. I hope I'm not being offensive with being too nice. What do we have here? I'm looking for Editor Wars. Did I keep it up? Probably this one. Okay. Where was it? It was humor. Due to the unintuitive character sequence to exit VI, hackers joke that there is a proposed method of creating pseudo-random character sequences by having an unfamiliar user with VI seated in front of an open editor and asking them to exit the program. I don't know why I just typed smiley face on that one. I don't usually type when I'm... Okay, so let's set this equal to true. Let's write this. Let's go over here. Let's make that. Let's see what happens. Let's run SciVL, Pong. Okay, for some reason this is working. Okay, so here's my Pong game, guys. I mean, you guys probably have seen it before. Basically, it's just, you know, you have a left and right paddle. It's going back and forth, yada, yada. It's great. Now, I have the ball move slightly faster every time it goes back and forth, which is great because it means that at some point the ball disappears because it's just moving too fast to visualize. Great. Oh wait, actually just started connection until I learned that. It changed the code into a smiley. Oh, did it? Ah, it's fine, doesn't matter. Okay, so here's what I'm thinking. Also, we have a platformer now. It's literally just a guy. If you press the spacebar, it shoots a thing. That thing is incorrect. I can't quite figure out how to get the laser to shoot right. But anyway, we have like a weird little other test thing. I was messing around. Or rather, my friend and I were messing around. Okay. Here's what I'm thinking. Let's just open up the platformer here. Okay. We have a ball here, and a ball like over here or something like that. And we just shoot an asteroid. So we have like some sort of indication of where the asteroid is going to be shot over here. And we shoot it, and it just does its thing. You know? Okay, James, I steal your idea. I'll make a Pong game in C++. Now I can use search in Vim. Well, yeah, searching's straightforward. Everyone can search in Vim. It's easy. Okay, so what I want to do then... Here's what I want to do. I want to do... cd git checkout beta. And let's do git merge Thomas. Make... Oh, I should probably make clean. Make. Give it a second to do its thing. Any Vim errors here? Wait. I use VI for everything. Guys. Hemmert, what are you doing? What is this? What is this nonsense? Oh, yeah. When I was going to write the VI video, the how-to VI, I was actually going to, at some point, like put some incredibly unintuitive character sequence forward to do something incredibly simple and be like, oh, it's easy, you know, like how I, for example, put comment blocks. So let's do VI check. Comment block is done this way. I type in I, then dash star, escape, 76A dash, that puts 76 A's in there. Then I type in A dash dash, YYP, O, star, YYPP, and then I go down here, X, A R star dash, right? So like it's incredibly unintuitive, but kind of neat, you know? I use CMake for my C++ project, and I was wondering how would I build and run using Vim. Wait, what do you mean how would you build and run using Vim? When you use CMake, you create a CMake lists.txt file or something like that you kind of go through. It's still the same thing, CMake dot. So far as I'm aware, NeoVim is where it's at. I don't know how to use NeoVim. If you had a proper chat, you'd see it. I'm sure I would. Had another session where you make directory build, CMake, make. Oh, yeah, that's another thing. I wanted to go through make files. Yeah, make files. I like make files. Now, I didn't like them when I started, but hey. If you use CMake, you need Visual Studio? What? Wait, what do you mean if you use CMake, you need Visual Studio? That's not true at all. Here, let's just go. I'm going to open up a new terminal. I'm just going to... Is that the right size? No, this seems big. There we go. That's the right size. Let me just make it bigger than this terminal here. And let me just make some CMake code for you. Wait. No, I like make files. CD projects. Here's a project I have that uses CMake daemon simulation code. Literally all you have to do to use CMake is CMake dot make the directory and then just make that. I had an error, but I promise that's how you typically do it. You have to be joking. You have to be joking. Like, everyone, CMake is relatively straightforward to use from the terminal. Himmert said, Lordborn, just joking. Sorry if I missed something, guys. Anyway, so that's what we got there. Okay. So, how does the scientific visualization library work? We just run scivl. We give it some sort of resolution. We don't actually need a resolution here because the default resolution is 1000 by 1000. Then we give it some sort of simulation type. This type, platformer. We can also do STD for standard. And maybe a couple others. I don't remember what else we have. But the big ones are... Oh, Fourier. Here. And this is the Fourier transform example that we had before. It's literally just, here's your Fourier transform. There's your peaks. You know, we can move the peaks around. And that's all it is. This is one of the many examples we've done. So what we want to do is some sort of general way to do, so ginger power. So what we want to do is some sort of general way to do this kind of game thing. So how are we going to do it? Let's take a look at what files we have. ls source, parg.cpp. We should have a platformer.cpp. Good. Everything seems to be working okay. Right, quit. So I guess what I want to do is, do we have a Fourier.cpp? Let me see. What do we have here? Platform.cpp, shaders, testpong. Is it in testpong? Don't tell me it's in testpong. vi source, testpong.cpp, Fourier. Oh, update FFT is there, isn't it? Okay. So let's change testpong just to test.cpp. So let's go to cd source, and let's move... If you need a Linux-based IDE, you could try Qt Studio. It will help you set up CMake, just like Visual Studio. Wait, are you guys actually... So, seriously, for CMake, though, you put all your files that you want to make into your CMake list.txt, and then you literally just make it. It's super straightforward. In my opinion, at least I thought it was, unless I'm doing it wrong. Anyway, so I want to move testpong to another file name, which we'll call aux functions.cpp. Yep, that's what I want. Now let's go into vi source. Actually, what am I going to do here? cd include, and let's move testpong into aux functions.cpp, and let's go into dang it. Move aux functions.cpp, aux functions.h. Okay, good. It's called Qt Creator. Yeah, I think a lot of people like Qt Creator. It's one of those that I think a lot of people Enjoy. I'm back. Had to go work out real quick. That's okay, Cranigan. I'm going to be working out in about 30 minutes. Again, I stream from 5 to 7 o'clock a.m. Japanese Standard Time pretty much every single day. Well, okay, never mind. I missed like 3 months. So I'm going to try to stream every day. We'll see what happens. Okay. Auxfunctions.h, vi auxfunctions.h. Let's go here and let's change these to what we want them to be. So let's do r auxfunctions h. Pop down here. I don't know why this happened, but $, get rid of all that. Okay, good. glsetup.h. So I think in vi source or glsetup.h, we're going to want to change, let's see, test. Nope. We're going to put this vi distributions. glsetup. What if I just make this? Make clean? Make? How's this making? Ah, there we go. That's what I was looking for. Vi source distributions.cpp. And let's go testpong, change this to aux functions. There we go. Make this. There's probably something else that required testpong. So basically what happened was, no rule to make target testpong. That's because if we go back a directory, go into the make file, we should have, where's testpong? There it is. And I want this to be aux functions. And let's make clean make. Give that a second. So I was able to build just by doing cmake dot. However, all it was build. How would I actually run the application? So after running, it's usually cmake dot, and then make. And then after that, you should have the application in the bin directory. Again, just to show this off, let's go here. Let's go into CD projects, daemon simulation codes. There's something, let me go into the README real quick. And let me see. I'm just going to run. Oh, where did I put cfits.io? I don't remember. Let me just try this. Then make that. Yeah, I have to remember where I put cfits.io. It's what we do for the input-output library. But, yeah, where did I put that? Let me, do I have it installed? I don't remember. Anyway, but yeah, so it's cmake dot, then make, and then everything should be in the bin directory after that. I just, for some reason, couldn't remember. I don't know. That particular one has a weird build condition. Hey, Capulera, what's up? Okay. Include aux functions. Fine. Vi source aux functions. Change this to aux functions.h. Let's make that. See what happens. Give it some time. Oh, I was thinking about making videos on some simple stuff that I do every day. So these videos would be on things like how to make a makefile, or how to use VI, or how to, I don't know, just simple things that I use every day that help me in my programming, like stuff, you know, help me with the programming and stuff. Now, you'll remember, if anyone was here a year and a half ago when I started doing this stream, which I don't know if anyone was, I was one of those people who really, really felt like you don't need all this computer science stuff. Now I kind of flipped. How to wake up at 5 o'clock a.m. every day. It's called insomnia. You just don't go to sleep. Okay. So let's talk about the scientific visualization library. You guys said, if I remember correctly, that you guys want to be able to like play this visualization, right? So like, again, when I say play it, I mean play it like it's a game. So like, for example, the Fourier visualization that we had, you were able to like physically move these guys around and that kind of stuff, right? So if you guys want to be able to do this, it's not a big deal. It's actually not difficult at all. Well, it is kind of difficult. Yeah, okay. Yeah, that's probably a good test. We can try doing it. This visualization will take longer to code. You might have been, actually. This type of visualization will take longer to code, but basically we can run it by just running scivl-s and then whatever we want to call it, so Verlet or something like that. And the nice thing about this is if we put all of the visualizations in the same visualization library, the scientific visualization library, then every one of the visualizations that we do, you know, all the algorithm archive visualizations will have all of their visualizations in the same. Yeah, I like this idea. Let's put them all in scivl, because that way, you know, worst comes to worst. I don't know. Yeah, I think this is okay. I think it's okay to put them all in scivl. So yeah, let's try it. And we'll see what happens. So tomorrow, since today we spent the whole day basically talking, catching up, which is great, and getting a very simple relay algorithm thing written, let's do tomorrow will be the visualization. Tomorrow and the next day will be the visualization. Hopefully we can get it all done by the end of the week, and then we'll have another day that's writing up the algorithm archive article, and another day which is doing something else. So that should be the whole week, I think. The problem is not waking up early. It's forcing myself to go to sleep early so I can then wake up early. Well, the thing is, if you wake up early, it's easier to go to bed early. Because the earlier you wake up, the more tired you get. Like, why not write in C++ metaprogramming templates? It's Turing complete. Oh man, templates. Templates in C++. Holy cow, they're hard. Okay, what was I going to say? I was going to say that... Yeah, so because I wake up so early, like at 8 o'clock, I'm spent. I usually cannot stay up past 10. 10 is as late as I can stay up. And at that point, like, I will fall asleep, like, anywhere. I like, just, I don't know, in my bed or something like that. It's crazy to think that you can actually fall asleep there. What was I going to say? Yeah, okay, I was going to say that the issue for me is that lately, my time I've been getting up has been earlier and earlier. Like at some point, I was literally waking up at 2 o'clock in the morning every single morning, and it was hard. So just, my suggestion is, if you're gonna get up early, don't get up super early. Get up at just a little bit earlier than you're used to, not a whole lot earlier, because it can make you miserable. Templates, yeah, I agree. Templates are a pain. But you kind of get used to them. It's like Stockholm Syndrome in a way. Okay, so let's go ahead and let's get this guy set up. Okay, so we're going to get this guy set up so that we have the simulation ready to run. We will call the simulation... what do we want to call the simulation? We will call the simulation Verlet. There we go. Simple enough. Learning them. Yeah, they're hard to learn. That's exactly why. I think the truth is once you learn them, they're okay. Yeah, exactly my opinion. I think the learning them takes a while, and they are kind of hard to use to start. I had to learn them on stream. There's a lot of things I had to learn on stream, and I really don't recommend learning this kind of stuff live, guys. It's hard. Okay. So here's how the scientific visualization library works. Let's go into ls. There should be a vi source SEL test here. This is the main function for the visualization library. It's relatively straightforward. Basically, we have process events, draw screen, set up OpenGL, STL initialize, set parameters. Like this is the whole main function. I wanted to keep it quite simple. However, these are quite complicated. So let's go into VI source and let's do distributions.cpp. Each distribution, which is a different simulation, has its own key to use, which is going to be what happens when you press the different keys. Functions for drawing, parameter set, and OpenGL kind of setup function or something like that. So for example, for Pong, the keys are quite simple. We have up, down, and W and S, which is up and down is for one bumper, WS is for another one. We have play Pong, which is the function that's used to play Pong. It's relatively straightforward. Okay, setup OpenGL takes a while though. Yeah, it takes a while. There's some things here that are quite messy that you guys are going to hate, but I think it's okay. So here's what I'm going to do. I'm going to go ahead. Is Fourier the last one that we have here? No, I think platform is the last one we have here. No, animation. We have animation? What happens if we run animation? Test Fourier, test animation. Oh, It doesn't exist. Interesting. Let's go into vi source gl setup dot, and let's do test anim. That's what it's called. Q. And let's do test anim. Oh, well, this is me seeing if I could do animations or not. Great, we can now do animations. Code written today? Alright, fine. Maybe I do need to put up Twitch chat so I can see what you guys are saying. Okay, so let's go ahead and set up the distributions so we're ready to go for tomorrow. Again, guys, sorry we were kind of, how do I put this? We were a little bit slow today. So what I'm going to do is I'm going to yank G, capital G, paste. What do we have here? Because I assume we'll be using very similar things for our case here. So what I'm going to do is change all these test anims to Verlets. Change it down here too. By the way, guys, this song that's playing right here, I don't know if you guys can hear it. Maybe the music is too quiet. It actually might be, because you guys said it was too quiet. Yeah, okay, fine. The song that's playing right now is I Don't Need It Anyway or something like that. It's a song that was bundled with Ubuntu a while ago. It was one of those songs that really made me want to remain using Linux. There's a good Pageladas community that works on chat client called Chatterino2. Oh, interesting. Yeah, okay, fine. I'll up the music tomorrow if that's okay, guys. I just... Hermit, Fort F, and Pagelada all work on that client. Oh, interesting. Cool, cool. So let's go here. And now what I want to do is the iSource GL setup, and let's put it over here. There's a lot of things I need to change. All right, I'm not going to try to defend all of my coding principles here. Yank 6 yank, paste. And we're going to say draw function is equal to, and let's just put Verlet in front of all of these. Here, there, there, and let's write and quit and go into vi include, and let's do, it's going to be distributions.h, and down here we're going to do yank 5 yank, and paste down here. Put an extra space here, and then we're going to change these guys to Verlet. So 9x should do it. There we go. And let's do Verlet here, there, there, and there. Okay. I think you forgot to change the if statement. I might have. Let me check. Oh, you're right. I did. Oh my gosh, I'm really bad at this. So we want to do this for Verlet. Does not exist. Pong Fourier. Okay, so let's make this. Hopefully it'll work. And then we should see the same weird test animation. Make clean. And this is something a little bit weird. For some reason, when I'm building this library in particular, it doesn't see an update to header files correctly. I'm not sure why. I think it's because of how I wrote the make file. I bet you it is. Undefined reference to Verlet function. Oh, what? vi source. It should be include, and we want to do distributions.h, Verlet function, Verlet key, Verlet par. They're all there. Undefined reference to Verlet function, Verlet key, par. What? 1 second, let me think here. Make clean. I just did this, and it didn't seem to work. Undefined references, though. Clearly I didn't link it correctly if it's not building, you know? Undefined reference. Let me think here. Let's go into source, and what do I want? I want GL setup. It should be reading distributions.h, which it is. vi source distributions dot, oh, sorry, include distributions.h. It is clearly in distributions.h. Key function parameter OGL function. 1 second. So let's do. Yep, I know it's a linking problem. So vi make file. Let's go ahead and add the. Oop. here. And let's see, I want to do operations parser parg. What did we call it? Aux functions. Then what else did we have? I think that should do it. One second, VI makefile. Wait a minute. This one was working. Make. It's only the most recent functions that we created. Is make clean not removing the object files? Oh wait, that one made. Why did that one make? What the heck? I don't know what happened there. Let me run SciVL just to check something. SciVL dash simulation, and we'll try Verlet. It should be. Yeah, okay. This is the simple test animation function that we had before. Okay, fine. It's I don't really understand, but it's working now. Let me check the make clean. Yeah, it's removing all the objects, so it should be okay. Huh. Yeah, I'm not really sure what happened there. I'm sorry about that, guys. It's working now, though, so that's okay. Okay, so what did we do today? I think... Right? I don't understand. Oh my gosh. I should look this up today. In fact, I definitely should, because I'm talking about make files tomorrow. Yeah, I definitely should. It's okay. It's good. It's good. Okay, well, it's 6:47 in the morning. I usually end it around 7 o'clock in the morning, my time, and I think this is probably a good place to go ahead and end it. We have everything set up for tomorrow. Today, I realized we didn't get as much done as possible as we could have, but that's okay. That's how every day happens. We get as much as we can get done, and then we kind of move forward from there. It's kind of a casual, let's just get together and code type of thing more than anything else. Glad to be back. I'll be back tomorrow for the next episode, and let me think. What do we want to do? So I think the schedule will kind of work this way. I think Monday we will implement a very crude, basic implementation of whatever algorithm we're doing that week. Tuesday and Wednesday we'll work on visualizing the algorithm. Thursday we'll work on writing it, and Friday we'll clean up. This is kind of what I'm thinking we'll be doing every week. If we need to, we'll also program on weekends, just depending on how it goes. Anyway, guys, I think I'm going to go ahead and close stream here, and I will see you guys tomorrow at 5 o'clock in the morning, Japanese Standard Time, where we continue doing the visualization. But for now, let me go ahead and get status, and let's go ahead and add these guys in here. So let's do get add. I think we can just do include star and source star. And let me check the make file, get diff make file. Yeah, let's also do get add make file. Now let's do get status. See what we got here. Looks like... Wait a minute. Let me see here. It said there was a deleted in source test pong, deleted here. So we should see new file, new file. There's 3 new files though. So get rm source shape functions chew.cpp. Get status. Wait a minute. How do I remove this? How do I unstage it? I have to think here. Get reset. Let's try get reset source shape functions 2. Get status. I think that reset everything. 1 second. What did it tell me? Include testpong, source testpong. Modified new file. We should be removing. Yeah, so we want to remove those files. So get rm include testpong.h. I know this is really stupid. I'm sorry, guys. And source testpong.cpp. Wait, what do you mean remove the cache? Sorry about that. So get status, and this should be all the changes we made. Yep. Okay. How do we remove the cache? Anyway, get commit. Let's see. M changing name of test pong.cpp. I'm adding in new distribution for Verlet visualization. And, oop, that was not what I meant to do. There we go. Git push, origin, beta. And that should be that. So it's now in the beta directory. Sorry about that, guys. Again, my Git knowledge may not be up to snuff. I need to look into that again. Anyway, guys, that is it for the day. So we have a very simple Verlet algorithm working, just dropping a ball from X meters high. Seems to work okay. Now we just need to implement it in the weird asteroid case that we're going to try and see how that goes. Outside of that, I think we're pretty good to go ahead and end the stream here. Gosh, I cannot speak. But that's all for the day. So have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you around next time for the next episode of Simuleos when we get started on this visualization and get things, I don't know, kind of up and running for the Arcane Algorithm Archive. Hopefully this will turn out kind of fun. You know, I'm excited to do an algorithm a week. I think this should be straightforward enough that we can do together, and I think it should be fun. So anyway, guys, I'll see you around next time. Bye, guys.